Here we have a pump characteristic curve showing head in feet and pump efficiency versus the capacity in thousands of gallons per minute. So looking at the pump curve for a specific or a particular impeller, the head curve shows feet of head for a given flow rate. We also need to put the efficiency curve for that impeller. So efficiency is the pump efficiency for a given flow rate. So this shows you the efficiency of the pump versus head for a given flow rate. And you can see that we have the peak efficiency point right at the top of the efficiency curve. If we come down from that peak efficiency point to where it intersects the head curve, we can find that best efficiency point, the BEP. The best efficiency point is the flow at which the pump operates at the highest or optimum efficiency for a given impeller diameter. If we come across to the left from that point, we see that that head is about 60 feet. If we come down from that point, we can see that the flow at 60 psi is approximately 10,500 gallons per minute. Well, now if we put the brake horsepower curve on here, we can see the power requirements. Brake horsepower is the power required from the motor to drive the pump at a given head to deliver a given volumetric flow rate. If we draw a line over from the brake horsepower curve from where the flow rate intersects the brake horsepower curve, we see that this requires about 200 horsepower. Well, now I want to take a look at the difference between series operation and parallel operation. When pumps are in series operation, where one pump discharges into the suction of another, what we see is an increase in head, but no increase in flow rate. So series operation will increase the pressure or increase the head, but it will not increase the volumetric flow rate. And here we can see the difference in head. So series operation increases head without increasing the volumetric flow rate. Well, in parallel operation, if we have one pump with its curve displayed here, if we added a second identical pump, the curve would look like this. And what we see with parallel operation is that we have an increase in the volumetric flow rate without increasing the head.